good morning, good afternoon, good evening, not good night, otherwise you all are going to sleep. So let's start the video. In this video, we are going to discuss about your acid and bases. We are not going to discuss about salts. Why? Because salt is a different topic. So in the next video, we will take that topic. But here we are going to discuss only about acid and bases. So there are three theories which will clarify all your doubts regarding acid and bases, because there are some species which looks like acid but actually they are not acid. They may look like base but they are not actually bases. So how to identify that we are going to discuss here, and I'm going to give you three theories. Okay, so the first theory is for acid and bases. The first theory is Arrhenius theory. Maybe you would have heard about this theory. Arrhenius theory is the simplest theory, a simple theory which says that acid, when dissolved in water, furnishes H positive ion. Bases, when furnished in water, dissolved in water, furnishes OH negative ion. This was Arrhenius theory. So according to Arrhenius theory, acid are those chemical species which when dissolved in water furnishes H plus ion, and bases furnishes OH negative ion, that is hydroxide ion. So let us take some example. For example, the simplest acid you know is HCl, and a simple base that you know is NaOH. So when you furnish it in water, it gives you H positive plus Cl negative. Very easy. NaOH, Na positive plus OH negative. So according to Arrhenius theory, HCl is an acid. Why? Because when it is dissolved in water, it furnishes H positive ion. NaOH is a base. Why? Because when it was dissolved in water, it furnished OH negative ion. So this is the example for Arrhenius theory. According to Arrhenius theory, this is the way how you are going to identify whether a species is acidic or basic in nature. Acidic H positive ion, basic OH negative ion. So copy it, Arrhenius theory. The first theory was Arrhenius theory, and according to this theory is based on H positive and OH negative ion. Now let us move on to the second theory, which was given as Lorry-Bronsted theory. Second theory was Lorry-Bronsted theory. Lorry-Bronsted theory. This is also a theory which identifies a species for its acidic or basic nature. Third nature is salt, that we will discuss. So according to Lorry-Bronsted theory, acid are the species which gives out H positive ion, just like Arrhenius theory. But here he defined bases as those species which adds H plus ion. This arrow indicates addition. Here it indicates addition. So we can say that acids are H plus donator and bases are H positive acceptors. This was Lorry-Bronsted theory. According to this theory, acids are those chemical species which donates H positive ion, and bases are those species which accept H positive ion. For this also I will give you an example. Let us take an example of ammonia. So ammonia never gives H positive ion. It always accepts H positive ion to become ammonium ion. So according to Lorry-Bronsted theory, ammonia is a base. Why? Because ammonia accepted H positive ion, so ammonia is a base. I hope it is clear. And acid are those which donates H plus ion, that you already know. HCl, H2SO4, H3PO4. Any acid you can take. Suppose you are taking this phosphoric acid. So it will give out 3 H plus ion plus PO4 charge 3 negative. Now how to know whether the ions that you have given here, that ions that you have made in the right hand side, is a correct one or not, whether it is correct or not. So it's very simple. You have to maintain the neutrality, means the charge should be neutral. How? See, if I break this H plus, there are 3 H plus, let me make it simpler, H positive and H positive. Hope it is clear why I am writing 3 times, because 3 H plus ions. Next is your phosphate ion, PO4 3 negative. So actually you got 4 types of ions. Now take out the charge, positive and negative. So plus means plus 1. By default, plus means plus 1. Again plus 1, again plus 1. So overall there are 3 positive charges. Plus 1, plus 1, plus 1, plus 3. And next one is PO4 having charge minus 3. So now see whether it is giving you neutral or not. Is it getting neutral or not? It is getting neutral, 0. It means that the ions that we have made in the RHS side, that we have given in the RHS side, is correct. Okay, let us take another example. Suppose let us take example of H2SO4. Now how to know whether you have written it correctly or not. Suppose this is H2SO4. Let me break it. Suppose I am doing a mistake. Suppose I did a mistake by writing H positive plus SO4 2 negative. Now how will I get to know that I have done a mistake? I will get to know because when I will add the charges, plus 1 and here it's minus 2. You can easily observe that it is not getting neutral. Neutrality is not maintained. So from here I will get to know that somewhere I have committed a mistake. Then I will check this and I will get my mistake as I had to put here 2H plus. Now plus 1 will be replaced by plus 2 minus 2 again 0. So now this is correct. Earlier it was not correct. Why? Because it was not giving overall charge as 0. So in this way you can break an acid or any other species into its ionic form, into its ions. Okay. So I hope Lowry-Bronsted theory is clear to you. If it is an acidic species, it will donate H plus. If it is basic species, it will accept H plus. Now, when these two theories were that much sufficient, then why there was a third theory? What was the need of third theory? That we will get to know after this. I hope you would have copied this. So our question is, if two theories were sufficient, what was the need for the third theory? Third theory is your Lewis theory. Very important theory. Lewis theory. Now why it was important? It was important because in both first, that is Arrhenius theory, and second Lowry-Bronsted theory, it was required that you have to dissolve that species into water. Means aqueous solution was necessary. Aqueous solution was necessary, otherwise you won't get whether it is furnishing H plus ion or it is furnishing OH negative ion. So every time it was not possible to have an aqueous solution of every species. So then came your Lewis theory. This theory is an electronic theory based on electrons. First of all, you should keep in your mind that this theory is based on electron, not on H positive or OH negative. Your first theory, Arrhenius, is based on H positive and OH negative. Second theory, Lowry-Bronsted theory, is based on H positive, acceptance or donation. Third theory is not at all based on H positive or OH negative. It is based only on electron. It's an electronic theory. Now let us go back to the same example. Looking at NH3, the student, those who don't know the correct way of identifying acid and bases, looking at NH3, what they will say? They will say that it is an acid. Why? Because it contains 3H here. A simple answer that will be given by an average student who does not know the theory, how to know whether it is acidic or basic. Just by looking at this H, he will say that this is a acid. This is an acid because he is only observing here 3H. But NH3 actually is not a acid. It's a base. According to Lewis theory, how we will get to know? See, if I make the structure of ammonia, I hope you would have studied the structure of ammonia in your class 9. Polar covalent structures. Under that comes your ammonia. So let us see N. Try to draw it with me. Okay. So if I take the configuration of ammonia, it's 2, 5. Configuration is 2, 5. So let me make it 1, 2, 3, 4 and 5. Only I am writing the structure diagram for nitrogen right now. Okay. So the configuration of nitrogen is 2, 5. So 2 comma 5 means valence shell has 5 electrons. I don't have anything to do with the inner electrons. They are stable, duplet state. So we are interested in only valence shell. So valence shell contains 5 electrons. Now, how to know how many hydrogens can be attached to any element? See, it's very easy. Again, you have to think about octet rule. Octet rule says that in the valence shell there should be 8 electrons. Octet means it comes from octa word. Octa means 8. So just see 5. Valence shell contains 5 electrons. How many more are needed for octet? 5 are already there. You need 3. It means 3 hydrogen. Because a hydrogen can give only a electron, single electron. Let us take example of carbon. Very easy. 2 comma 4. Now you can see how many electrons are left for octet. 4 electrons. It means 4 hydrogen will be added. That is why it makes a compound CH4, methane. I hope it is clear. So by looking at this structure, now I hope you know how many hydrogens will come. 3 hydrogens will come. Why? 5 plus 3. So let me attach hydrogen 1 here, showing it by dot. Another hydrogen by dot. Another hydrogen by dot. Now see, this hydrogen cannot go for octet. It will go for duplet. So let's make it duplet. A duplet for hydrogen. Another duplet for third hydrogen. Now nitrogen have given 1 electron to hydrogen. So it will also take that electron from hydrogen. It is called as sharing. So nitrogen here is going to take electron in this way. Now see, hydrogen duplet, this hydrogen duplet, this hydrogen duplet. Now see for nitrogen, already 1, 2, 3, 4, 5. 6th from first hydrogen, 7th from second hydrogen, 8th from third hydrogen. It means octet is completed. So for nitrogen, octet is completed, and for hydrogen, duplet is completed. I hope up till here everybody would have understood how we have drawn this structure, because after this I am going to tell you how I can say that ammonia is a base according to electronic theory, not according to your Lorentz-Bronsted theory. Okay, if you are still confused, pause the video, go back, again watch that video. Okay, so I'm continuing from here. So octet, duplet, it is maintained. Now see, when we have drawn this structure, now what we are observing is nitrogen used its 3 electron, 1, 2, 3, but these 2 electrons were not used. It means it has extra electron, and this extra electron we call it as lone pair of electron. We call it as lone pair of electron. It means this structure means overall ammonia structure contains extra electron. As I told you, lone pair means extra electron. They contain extra electron. So just see, NH3 has lone pair. Now this is a question for you. Try to think whether ammonia can accept electron or ammonia can donate electron. This is a question for you. Try to think just ammonia can accept electron or ammonia can donate electron. Definitely ammonia will go for donating electron. Why? Because NH3 has lone pair means extra electron. If you add more electron to ammonia, charge will increase. If you add more electron to ammonia, charge will increase, negative charge will increase more, and you know, more charge, more unstability. More charge means more unstability. That is why helium does not have any charge. Neon does not have any charge. Argon, krypton, xenon, radon, they don't show any charge. Why? Because they are stable. Stable means no charge. So if ammonia adds more electron, it will increase its more negative charge. Why? Already it has lone pair of electron. Electron means negative charge. So ammonia already have negative charge, and you are providing it more electrons. It means it will become more and more unstable. It means it won't go for addition of electron, rather it will go for minus electron. Why? Because already negative charge is there on ammonia. Now if it donates electron, what will happen? It will acquire positive charge. So this positive charge will neutralize the negative charge of ammonia. Think it very carefully, look at it very carefully. Ammonia has negative charge over it because of lone pair of electron. So when it will donate electron, it will acquire positive charge. It means its charge will decrease because already it has negative charge and you are providing now it positive charge. How? By making it to donate electron, or itself it will donate. So when it will donate electron, this negative charge will reduce. Now reduction of charge means gaining more and more stability. Donation of electron means it is going to increase its instability because it will acquire more and more negative charge. So instead of acquiring negative charge, it is going to acquire positive charge. How? By donating electron. Now here comes your Lewis theory. According to Lewis theory, bases are the species which donate electron. It is totally opposite to your Lorentz-Bronsted theory because their charge is different. That is not negative charge, that is positive charge. So don't get confused that there we are saying bases are those which accept H plus and acid are those which donate H plus. There the charge is positive. Here I am talking about negatively charged subatomic particles, that is electron. So according to Lewis theory, bases are those which donate electron and acid are those which accepts electron. Now you can see that in this theory you are not at all interested in aqueous solution. You are only interested in electron, whether electron is being donated or electron is being accepted. Okay, so if any of the chemical species, let us forget about ammonia, let us think that XY is a species. Now if XY donates electron, if XY donates electron, definitely XY then is a base. But if XY is adding electron, then XY is an acid according to Lewis theory. So I hope these three theories are clear to you. First was your Arrhenius theory based on H positive, OH negative. Second theory, Lorentz-Bronsted theory based on acceptance and donation of H positive ion. And third one, Lewis theory, which is a modern theory. Mostly we are using this Lewis theory only because we may get confused by looking at species like this having H part. H part means acid according to Arrhenius theory. Okay, so the most trusted species right now is Lewis theory. Now do not think that other theories are of no use. Other theories are also of use. Let us take an example. Suppose I am going to talk about H3PO4, phosphoric acid. Now instead of going into this structure, whether electron is being donated, whether electron is being accepted, that will be a lengthy process. That will be a lengthy process if I go through Lewis theory. So I'm not saying that Lewis theory is the only important theory. It is a theory which is mostly used, but I cannot say that, we cannot say that it is a very trusted theory or it is a very easy theory. It is a trusted theory, but it is not an easy theory. Always we cannot say that Lewis theory is easy theory, so we will go for Lewis theory. If you go for Lewis theory here, you will get confused. You will yourself get confused. Okay, but better than going for Lewis theory, I can apply here Arrhenius theory. So I will make it to break like this: 3H plus PO4, 3 negative. So easily by Arrhenius theory, I got to know that H3PO4 is an acid. Okay, that is why all the three theories are very, very important. Do not focus on a single theory. Most of the students are only focusing on H plus and OH negative. Just think how you are finding out whether something is acidic or basic. This is what you are doing, H positive and OH negative. So that you won't stick to this theory only. That is why I taught you two another theories, Lorentz-Bronsted theory and your Lewis theory. So have your grip over all the three theories. Okay, but you should know each and every theory. We don't know which particular species will be easy for you to know by which particular theory. Suppose it's XY, so I cannot say whether I will go for Arrhenius theory or I will go for Lorentz-Bronsted theory or will I go for Lewis theory. It depends which of the theory is easy. Which of the theory is easy for this particular species to find out whether it is acidic or basic. So I hope it is clear to you what is acid and bases, and in the next video we are going to talk about salts. So first clarify all your doubts regarding acid and bases according to the electronic theory, according to the ions, and after that we will study about salts. So I hope acid and bases now will be clear to you. So keep growing, keep studying. Thank you.